Okay everyone, here are a couple of sample problems that we didn't have time to do in class. Parametric equations are when you have an x variable described by a third variable t and a y variable also controlled by that third variable. Our goal is to eliminate the t and to take these two, this pair of parametric equations, and write it as a single typical equation where y is some function of x. So y equals something with only x, no t. So all I need to do is take and solve this. The first step is solve for t, and then I'm going to sub in for that. So when I do that, I just divide both sides by 10, and t then is equal to x over 10. Alright, so I'm going to drop off. That's just telling me that my variable is t, so I don't really need that here. Then I take x over 10, and I put it in place of t right there. So y is equal to 90 minus 4.9 x over 10 squared. And strictly speaking, I'm done. I have written it as a function of x. It's usually nice to clean this up a little bit. That 90 isn't going to change. If I square the top and the bottom, I'm just multiplying x over 10 by itself, I get x squared over 10 squared, which is x squared over 100. 4.9 divided by 100, I just get minus 0.049 x squared. Okay, so that might be what it looks like in the back of the book, even though that's totally correct also. I'm just cleaning it up. This one is a little bit different. All right, here, just to give me some room to work, I'm going to use what's called the Pythagorean identity. If you go back to the trig ratios, you can check in our book, but if I have a sine squared of some angle theta, and I'm adding it to a cosine squared of that same angle, all right, it's always equal to 1. Try it on your calculator. The sine of, say, 20 degrees, square that, add it to the cosine of 20 degrees squared, and you're always going to get 1. All right? So I can take and rewrite this in terms of only x and y by making the following substitution. Okay, sorry about that. I had a phone ring. What I do is I solve each of these for just the cosine. All right, so if I solve this for the cosine, I'm going to get x minus 3 when I take 3 away from both sides, and then I divide by 6. And I get that is equal to the cosine of t. And I solve this in the same way, and I get y plus 2, when I add 2 to both sides, divided by 6 equals the sine of t. I just put these parentheses in, so cosine here goes in right there, and that's x minus 3 over 6 squared, and then this is y plus 2 over 6 squared, and that's equal to 1. And then what I do is I clean that up. I just do the math to clean that up to save a little bit of space. Okay, that is going to be FOIL it out, and I'll just get y squared plus 4y plus 4 divided by 6. Actually, you know what? I'm not going to do that. I am going to get y by itself because I want an equation y equals x. So I'm going to have this be y plus 2 over 6 squared equals 1 minus x minus 3 over 6 squared. And then I'm going to take the square root of both sides. So there I do that. And then I'm going to multiply both sides by 6. So I'll put that in brackets and times it by 6. And that's gotten rid of the 6. And then I subtract 2. So then minus 2. Alright? A little bit ugly there with my marker, but nevertheless, that is the way you get y by itself. Y by itself. It's no different than when we did the logarithm problem and we had to peel away the layers. So I peel away the layers to get at that y by itself, first subtracting this, then square rooting it, then multiplying both sides by 6, then finally taking away the 2. And so y equals 6 times the square root of 1 minus x minus 3 over 6 in parentheses squared minus 2. Okay? There you go. Thanks.